What do you got?
So I have a quiz tomorrow on page 115, 116, and 117 in the textbook.
Okay, which problems?
Can we do number 9 on page 115?
Yeah, it's the fifth root of x.
Mm-hmm.
I have it right. Let's use black. I'm using a different drawing program merely because my eraser stopped working on my other one.
Oh no.
And it's got to be a software problem because it works fine on this program. This should be just as good. I just maybe have to get used to it.
Yeah.
The one thing, and you're supposed to just find the derivatives of all of these. Okay. The one thing you're going to find is that radical signs don't work well with calculus. You want to convert all your radical signs to fractional exponents. So how do I write this with a fractional exponent?
X to the negative 1/5.
No, positive 1/5.
Oh, okay.
That's what that means, is the fifth root of x. If it was negative 1/5, then it would be 1 over the fifth root of x.
Oh.
In other words, if this was the problem, f of x equals 1 over the fifth root of x, then that would turn into x to the minus 1/5.
Oh, got
The difference?
Yeah.
Okay. Now, just apply the power rule. What's f prime of x equal to?
1/5 of x times negative 4 over 5.
Okay. Now, there's nothing wrong with that answer. That's perfectly fine. But depends on your teacher. Your teacher may have kind of an unwritten rule that if they give you the problem with a radical sign, give it back to them with a radical sign, the answer.
Yeah, that's what he said.
Okay. So how do I reintroduce the radical sign and also positive? I want to rewrite this thing.
So it would be 1 over.
We can do it. Let's do it in 2 steps. 1/5 times 1 over x to the 4/5. And now put that in radical format. That's 1/5 times 1 over what?
The root of x to the 5th.
It's the 5th root, but it's x to the 4th.
Okay.
That's the way to write it with a radical sign. And I can, of course, multiply and put the 5 in front. Let's see if my eraser works like I think it does. Yeah, it works fine. I can't believe it stopped working on the other program.
Yeah, that's weird.
How could it stop working? I know. So anyway, that is an answer that's probably preferred. Although myself, I would probably stop there. I don't know that I would go to all the trouble unless the teacher has specifically said. Now maybe the teacher said just always have positive exponents, in which case that would be the answer. But if he said always put it back into radical format, then you'd want to convert this. X to the 4/5 is the 5th root of x to the 4th.
Okay. Gotcha.
What else? You want to pick and choose?
Yeah.
Okay.
Can we do number 18.
Mm-hmm. Now, when you have a polynomial that has 3 terms in it like this,
Mm-hmm.
the derivative of the polynomial is the same as the sum or difference of each term. In other words, if I want to differentiate that, it's the same as differentiating that minus the derivative of that plus the derivative of that. So it's actually pretty easy to do.
Mm-hmm.
What's the derivative of the first circled term?
6x to the second.
Uh-huh. Second term?
2x.
And third term?
0.
3.
Oh, 3.
Notice why it's 3. Start with the exponent, multiply, subtract 1 from the exponent, so you get 3 times x to the 0th power. Well, anything to the 0th power is 1. So that's why the derivative of 3x is just 3. It's always that coefficient. If this is to the 1 power, it's whatever the coefficient is.
Okay.
Okay. What next?
Can I do?
In other words, sums and differences are easy. So 13 is easy. That's just 3 separate derivatives.
Mm-hmm.
14 is easy. 18 is easy. 17 is easy. What's difficult sometimes is products. What have you had so far? Just the power rule?
We've had the power rule and the product rule too.
You have had the product rule? No, the product rule comes up next. I'm looking at page 119. That's the product.
Yeah, I think, I don't think
None of these problems are going to be the product rule. So if your test is just on this page, you said 115 and 116? Yeah, you're not going to get the product rule.
Okay.
So everything will be adding and subtracting. How about 19? Let's have a look at 19. Let me pick one.
Okay.
We'll use theta. In other words, I didn't write this correctly. That needs to read theta, and that needs to read theta. In other words, we have a function of theta, is what that means. You wouldn't want to write f of x. F of x means your variable is x, but in this case, the variable is theta.
Okay.
First of all, pi over 2 is just a number.
Okay.
So what's the derivative of sine?
Cosine.
Okay, so this becomes pi over 2 times cosine, first part. And what's the derivative of cosine?
Negative sign.
And make very sure you do not drop negative signs. One of the easiest things to do in calculus is to drop negative signs. I mean, you're just getting started, but trust me, it's not going to be long before you have an expression that has like 9 negative signs in it.
Ooh.
All the way across the page. And you have to turn that into a number. So, and it happens to be negative signs. There's so much subtraction going on in calculus that you end up with tons of negative signs. So just be very, very careful not to drop a negative sign. And of course, those 2 negative signs turn into a plus.
Gotcha.
and I want to remove the parentheses. So that's the answer. And let's talk about terminology for a minute. Write that like that. So all kinds of ways that mean the same thing. dy d theta means the same thing as f prime of theta. Delta y over delta theta means the same thing, first derivative. There's a couple of others. I can't think of them off the top of my head. But these all mean the same thing. There's some advantage to some over, y prime means the same thing.
Okay.
The bad thing about y prime is it does not tell you the variable that you're taking the derivative with respect to, whereas these first three do. This tells you that it's dy d theta, whereas y prime could be dy dx, could be dy of whatever the variable might be. So it is the shortest way to write it, and nothing wrong with using y prime as long as the variable is well known. Thing I haven't figured out is how to go to another page without going through this question right here. Probably make the settings so it wouldn't ask me that, but all right. Same thing with 20. That's pi cosine of t. Pi is just a number. In other words, you're going to treat the pi no different than you would treat a 3 or a 4 or 7.
Okay.
You pick next.
How about 24?
Okay. Again, we've got the sum of two different types of functions, which means we can take the derivative of this one and add it to the derivative of that one. In other words, treat it like two separate problems. Okay? Now, the first thing we want to do is rewrite that so that it's in the numerator. So how can I rewrite that so that I can use the power rule?
So would it be the fifth root of...
No, the 5 is in the numerator already, so I'm going to leave it in the numerator.
5 times the third root of 2x?
Well, let's go ahead and expand that. Notice the 2 is in the parentheses also. So 2x cubed is 8x cubed.
Oh.
So it's actually 8 x to the minus 3 and that 8 belongs in the denominator. Hey, rewrite. Make sure you understand. What I'm doing here now. I'm getting it. You hearing that echo?
Yeah, a little bit.
Wow, it's pronounced. Full second delay.
Yeah.
What the heck? Did you do anything in your
You're cutting out a little bit.
Did you do anything different on your end?
Nope, I don't think so.
It just happened about 5 seconds ago. Let's try. Try logging out and logging right back in. I won't change anything. I'll leave the same meeting ID number. Yeah, let's see if that's any better.
Right.
Good.
I think
I
that's
didn't
better.
hear the echo. All right.
No.
Let me start this problem again. I kind of screwed it up. Okay. First of all, let's expand the bottom so we get rid of the parentheses. That becomes that, right?
Okay.
In other words, so far I haven't changed it. Now I want to get that x in the numerator because I know how to use the power rule, but I can't apply the power rule until the x is in the numerator.
Mm-hmm.
So to do that, it becomes 5/8 x to the minus 3 plus 2 cosine of x. And now I can differentiate it by just applying the power rule. Hold on. Y prime is equal to what?
To negative 15x over 8 to the second.
Yeah, I figure out the coefficient first and then subtract 1. When I subtract 1, what do I get?
To the to the negative 4.
Right. Okay. Let's go on to this one. What's the derivative of cosine?
Sine.
Negative sine. So this plus sign turns into a negative 2 sine of x. We'll get back to that in a second. I'm going to show you a good way to memorize that. And now if I want to use, in other words, if your teacher has said, okay, give me the answers with all positive exponents, then I'm going to write this way, minus 15/8. And I'm going to put that x back in the denominator where it started. And that's a better answer. That bottom line is the best answer.
Okay.
Okay? All right. Let's talk memorizing your trig derivatives.
Mm-hmm.
There's a sequence, there's a pattern to it that you might not be aware of. You have to memorize the derivative of that one. Okay? And let's write cosine there and leave that blank for a moment. You have to memorize the derivative of tangent. What's that?
I don't know.
Secant squared. One way to help memorize this is you remember your trig identity where tangent squared plus 1 is equal to secant squared?
Mm-hmm.
Well, know that tangent goes with secant. Okay? And then cotangent, I'll get to in a second. But the third one, secant of x, the derivative of that is secant tangent. Okay, that's another one you just have to remember. But the second one, you familiar with cofunctions?
Yeah.
Okay, the cofunction of sine is cosine. In other words, the cofunction of a trig function is just the word, the trig function with the word co in front of it. Unless it already has co in front of it, then you drop the co. Okay?
Mm-hmm.
So sine and cosine are cofunctions, tangent and cotangent are cofunctions, secant and cosecant are cofunctions.
Mm-hmm.
Now, when you take the derivative of each cofunction, the ones that I've left blank, that one, and that one, they're all negative. And what goes to the right of the negative sign is the cofunction of what's above it. So that's sine of x.
Mm-hmm.
This one is what? It's the cofunction of secant?
Tangent. Oh,
Cosecant. Remember, cofunctions are not the same as reciprocals. So don't get them confused. But then on the very bottom one, what's the derivative or what's the cofunction of secant?
Cosecant.
And the cofunction of tangent?
Cotangent.
That's how you remember the second three. You don't really have to memorize the second three. In other words, you can call that primary ones. You do have to memorize each of those. There's no getting around it. 1, 2, and 3.
Mm-hmm.
But then when you're taking the derivative of the cofunction of 1, 2, and 3, it's always going to be negative, and the answer is, in other words, you can see where you do not have to necessarily memorize the 3 check marked ones, right?
Yeah.
And it's not always obvious because they tend to teach you, the first 2 are the top 2 that they teach you. Mm-hmm. So you tend to memorize cosine as being negative of sine without realizing that it's the cofunction of sine also.
Yeah.
But when it comes to memorizing these other 4, it's very helpful if you can narrow that down to only have to memorize tangent and secant. And these aren't that hard to memorize. Tangent, you'll get used to that pretty quick, that it's secant squared. And then secant's a little unusual in that the derivative is the secant times tangent. Mm-hmm. But again, notice tangent goes with secant. So it fits your trig identities. But this is a great way to memorize your derivatives of your 6 trig functions.
Yeah.
All right. You might even want to, I don't know that you need to take a picture of that, but it's going to definitely help you if you can think of it like this. Because then you only have to memorize 1, 2, and 3, and you can always figure out 4, 5, and 6. Mm-hmm. All right. What next?
Can we do number 43?
43?
Yeah.
Sure. I'm going to make this as easy as possible by writing y whenever I can, just to reduce the writing. You understand that y is the same as f of x?
Yeah.
Now, there is such a thing as the quotient rule. Not only is there a product rule, but there is a quotient rule that they haven't taught you also. And if they had taught it to you, you could use it. But there's actually an easier way to do this problem. And that's to split it up into 3 fractions. In other words, I've got 3 terms in the numerator, but only 1 term in the denominator. So I can split that up how? In other words, by splitting it up, I mean that's 1 fraction, that's another fraction, that's your 3rd fraction.
Okay.
So what does that give you?
So x to the 3rd over x squared
minus, go ahead.
3x squared over x squared plus 4 over x squared.
Now simplify those and write them all with x in the numerator.
X minus 3 plus 4 over x squared.
And write them with x in the numerator, like that. Because I want to use the power rule. I cannot use the power rule if x is in the denominator. I've got to have x in the numerator.
Okay.
Okay. Now, that's y. What's y prime?
So it's just x, right?
The derivative of x is whatever its coefficient is. 1.
Oh, okay.
Again, if you had it to do the hard way, I'll start with the 1 there. Well, the way you use the power rule is you start with the exponent as a multiplier. You subtract 1 from the exponent. X to the 0 power is 1. You got 1 times 1 equals 1. So whenever you have the x to the first degree, whatever its coefficient is its derivative.
Okay.
Okay. And what's the derivative of -3? Oh, look at that. Now my eraser isn't working anymore.
That's so weird.
That's what was going on before. It's almost like it works fine until I'm way over here to the right side of the page. Huh.
Oh, that's weird.
Yeah. What's the derivative of 3?
0.
And what's the derivative of the next one?
Negative 8x.
Yeah, it does. It works fine on this side of the page. It only doesn't work over here. Huh.
That's weird.
I wonder. That's where my GoToMeeting panel would normally be. I wonder if that's what's going on. I've got my GoToMeeting panel minimized, so it's not there, but I wonder if the software reads it as there. So what's the derivative of that?
Negative 8x.
Remember, subtract 1 from the exponent.
Oh, negative 8x to the -3rd.
And now let's rewrite that as simplified and with positive exponents only.
So, negative.
No, we still got that to deal with. That's 1.
Oh, yeah. 1 minus.
8 is in the numerator. In other words, the 8 is not, that -3 does not affect the 8.
Okay.
So I'm going to...
8 over x to the 3rd.
Yeah. And that's your answer.
Gotcha.
Okay. What else? Let me have a look at these from this section. 44 is the same thing. Break it up into 3 fractions. 45, you don't have a product rule yet, so distribute that. And then you'll have 2 terms, and you can apply the product rule on each term.
Okay.
You know what I mean?
Yeah.
Okay. 46, same thing. You don't have a product rule yet. Here, the kind of things that are going to require the product rule, let me just show you, is if I had this. I got to do the product rule because I can't distribute that x. In other words, I can't multiply those together to make it 1 or 2 terms. So I would have to do the product rule. And the product rule, I'll just give you a little bit of a heads up on it, is really quite simple. It's this times the derivative of that plus the derivative of the first one, the derivative of x times that. The way they, excuse me, y equals u times v, and both u and v are functions of x, then y prime equals u times v prime plus u prime times v. That's the product rule.
Okay.
And you use it whenever you have 2 things being multiplied together that you can't actually multiply. In other words, where you have to treat them as 2 different functions. All right. Did you give me a number? Let's try 40.
40, which one?
47?
Yeah.
It's the first thing to do?
Turn it into so that it doesn't have any radicals.
Right. Get rid of the radicals. Okay. What does that give us?
1 over x.
No, you're confusing radicals with negative exponents.
Oh.
That's x to the 1/2.
Oh.
When you take the cube root of x is x to the 1/3. Okay, so radicals merely convert to a fractional exponent with the denominator of that exponent being the root you were trying to take. In other words, to the 1/2 means the square root of x.
Okay.
Rewrite this one.
6 times x to the 1/3.
Okay, now differentiate. What's y prime?
1/4 x to the negative.
Always start with the exponent. Where'd you get 1/4?
Oh, I just wrote it down wrong.
Okay, I figured maybe, yeah, because there's no way you're going to get 1/4 there. So 1/2 x to what?
X to the negative 1/2.
Okay. Let's finish the problem before we go changing its format.
Okay. So
now here, start with the exponent and multiply it by that coefficient. That's what the new coefficient's going to be.
So 2.
X to what?
X to the negative 2/3.
All right. Now we got two problems. We want to get the radical sign back in there, and we want to eliminate negative exponents. So what's the best way to rewrite this term right there? Now, I have to admit that if you answered this on a test, you shouldn't lose any points. When you get to calculus, you kind of throw out all those rules that you need the radical sign in there. I mean, if you were in calculus for 3 months, I don't think the teacher would be saying, give me nothing but positive exponents. It's just not a factor in calculus. You'd be doing all kinds of work that was unnecessary if you always did that.
Yeah.
Because, for example, have you had second derivative? Let's say that they wanted to take the second derivative. Second derivative is just the derivative of the first derivative. It's really, okay? Well, if I had to take the second derivative, I would much rather it be in this format that I've got it in now, right?
Yeah.
In other words, that's the perfect format to use the power rule on. So I'm not sure how much effort. Are you sure your teacher asked you to change the format?
Yeah, he said on this test he wanted us to.
Okay, and does that mean positive exponents only and radical signs, or fractional exponents okay?
He said whichever way you see the equation given to you is the way he wants it back.
All right, so he wants positive exponents and radical signs. Okay, yeah. So first of all, let's get rid of the negative exponent.
Okay.
In other words, take that first term and write it with a positive exponent.
So 1/2 over x to the 1/2?
Yeah, and I can write it like that with just one fraction bar. Oh, okay. I don't need the 1/2 to be a coefficient. The key thing is the 2 needs to be in the denominator.
Mm-hmm.
Okay. And this one?
2x over...
No, the x has got to be in the denominator, but the 2 is going to be in the numerator.
Okay, so 2 over x to the to the positive 2/3.
Okay. Now the last step is to put the radical signs back in. What's this line?
2.
No. A 2 is in the denominator.
Would it be root 2?
Like, no. The 1/2 is not acting on the 2. The 1/2 is only acting on the x. So the only thing that needs to be in the radical sign is the x.
Okay.
You see how these two are the same?
Mm-hmm.
Okay. And over here, 2 is still in the numerator, x is still in the denominator, but now to put it back in the radical format, how do I do it? What's x to the 2/3 in radical?
The third root of x squared.
Yeah. So this is the answer your teacher would want.
Okay.
Like I said, now if you wanted to take the second derivative, I'd have a lot of work to do just to get it back to this state, which I would want it in.
Yeah.
So that's not necessarily a common policy in math, is to always get it back to what you started with. In fact, I would say it's not the common policy at all. Even though I kind of understand why he's doing it, but all right, what else?
Can we go on to 117 and do number 89?
Sure.
Or actually, it's on, oh yeah, 117.
89 is a good place to start. Now this time I'm going to use the F notation because it's going to help us answer this.
Mm-hmm.
Average rate of change is slope. That's what it means.
Okay.
Okay. So I want to do rise over run. Let me spell it out. It's slope. Average rate of change equals slope equals rise over run equals F of the bigger number 2 minus F of the smaller number 1. That's the rise, right?
Mm-hmm.
Over the run 2 minus 1. So what's F of 2? What is it?
2.
If F of t is 2t plus 7, what's F of 2?
11.
Okay. What's F of 1?
Is 9.
Okay. So what is this equal to?
11 minus 9 over 1.
That's the average rate of change. And that's what you're going to do on every single one of these problems. You don't necessarily need this, but you do need this. It's F of the big number minus F of the smaller number, all divided by the big number minus the smaller number. Okay. So let's have another one. You have a preference?
91.
Okay. So here F of x is equal to minus 1 over x. Now you'll notice that average rate of change is not a calculus problem. It's an algebra problem.
Yeah.
Algebra is perfectly able to handle slopes. Calculus is about instantaneous rates of change. If you had to sum up the definition of differential calculus, that's what it would be, the instantaneous rate of change. as opposed to the average rate of change. Well, notice what the problem is. When you do instantaneous rate of change, the rise is 0 and the run is 0. So that's where the calculus has to be brought in, is how do you figure out a rise over run of 0 over 0? Well, that's why they spent 2 weeks on limits, figuring out limits. Okay?
Mm-hmm.
So again, what's the general formula for average rate of change, the way I expressed it last time?
F of the bigger number minus F of the little number over the big number minus the little number.
Yeah, it might be F of A minus F of B all over A minus B or something like that. But it's always this for average rate of change. Okay, now let's go figure out what F of 2 is and F of 1, and we'll be halfway there.
Okay.
It's F of 2
is negative 1/2. Or, yeah.
F of 1
is negative 1.
And now what is that?
1/2.
Negative 1/2. The best way to do these, one step at a time and then simplify. Because look what happens here. We're dealing with a lot of negative signs.
Yeah.
And it's extremely easy to drop negative signs in calculus. So what's that answer?
1/2.
Right. Okay.
Okay.
Let's do a trig. Let's do 92 just because it's a trig function.
Okay.
And the interval from 0 to pi over 6. Okay, tell me what to do.
Okay, so first we need to find F of 0.
Okay. What's sine of 0?
0.
What's cosine of 0?
1.
Okay, good. Just want to make sure you weren't guessing.
No.
What's sine of pi over 6? What angle is that in degrees?
That is 30 degrees.
What's the sine of 30 degrees? That's one worth memorizing.
Is that root 3 over 2?
No, it's 1/2. Sine of 60 degrees is root 3 over 2. But kind of the foundation, if I'm ever checking my calculator and I don't know if it's in radians or degrees, the one I always do is the sine of 30. And if it gives me 1/2, I know it's in degrees. If it gives me some strange answer, I know it's in radians. Okay, so now what? What's the average? What's the slope going to be?
1/2 minus 0 over pi over 6 minus 0.
And what is that?
6 over 2 pi. So 3 over pi.
Yeah. Okay. Love these answers because notice we have to live with an irrational denominator. There's no way to rationalize that. Which I've never liked that rule anyway. I've never liked the rule where you got to rationalize the denominators.
Yeah.
That's just a consensus on mathematicians. There's no real reason for it. And this proves it because you can't rationalize pi. All right. What else? We got about 15 minutes. Not quite. I do have a 4:30 I got to go to. So, got 13 minutes. About some of these word problems, like 93. Is that something you have to do?
Yeah.
Let's do it.
Okay.
Okay, into the light here. All right. If we have a position function, I'm sure the one thing they've taught you is that velocity is the first derivative of position. In other words, S of t is position. S prime of t equals v of t equals velocity. And S double prime of t, the second derivative, equals acceleration. Okay, so they're giving you the position function here, which is S of t, and here I always use this notation just because position, velocity, and acceleration all use S of t, v of t, and a of t.
Right.
V sub 0 means the initial velocity when it's dropped. S sub 0 means the height that it's dropped from. So what's the position function going to be for 93A? In other words, let's figure out what S of t actually is, given what they've given us. Well, first part doesn't change. What's V sub 0?
The initial velocity?
What is it when you drop an object from the top of a building?
0.
Right. So that middle term goes away, and the only thing we're left with is S sub 0, which in this case is the height that it's dropped from, 1362. Okay. Now let's get V of t, the second thing they want. Now V of t is the derivative of S of t. In other words, I could write that as S prime of t if I wanted. And what is that?
So negative 32 t.
That's it. 1362 goes away. Determine the average velocity on the interval 1 to 2. So they ask about velocity, so they want us to figure out the average velocity on the interval 1 to 2. Well, let's do it exactly like we just did those average velocity problems.
Okay.
Tell me what to write.
So it would be negative 16.
Let's write it. Let's write out everything. In other words, what we need to know V of 2, right? And we need to know V of 1. So V of 2 is negative 64. V of 1 is negative 16. See that?
Yeah.
I got that? In other words, V of t is equal to minus 32t. That's its function. Okay. And now we want to do V of 2 minus V of 1 all over 2 minus 1. While you're doing that, let me go. My TV accidentally came on. Let me turn it off. Hold on.
Okay.
Didn't accidentally come on. It mutes for an hour, and when it runs out of an hour, it comes back on. on its own.
Oh, that's weird.
All right, so what is this equal to?
48.
And we got minus 64
Oh, yeah, mix.
a minus 16. Again, be careful not to drop the negative signs.
Mm-hmm.
So that's minus 48.
Yeah.
So that's the average rate of change. And that makes sense that it would be minus, because velocities, if something is moving down, it's a negative velocity. If it's moving up, it's a positive velocity. If it's moving to the right, it's a positive velocity. If it's moving to the left, it's a negative velocity.
Okay.
Since this thing was dropped from a building, its velocity is negative the whole way down, so its average velocity must be negative.
Mm.
Okay. And let's see what else they wanted to know. Find the instantaneous velocities. Well, what's that going to be? By designation, not the number. I know you can figure out the number, but what does it mean?
Is it when 1 second has gone by, what's the velocity?
No, what it means is v of 2. In other words, the instantaneous velocity is evaluating the velocity function at a particular time. So after 2 seconds, it's moving at 64 feet per second in a downward direction. At 1 second, it's only moving at 16 feet per second in a downward direction.
Okay.
Okay, and that makes sense also, right? Because if you drop something off of a building, it starts out slow and then accelerates. So it should be a greater velocity after 2 seconds than 1 second. But that's what instantaneous velocity means, is the velocity function evaluated at a particular time.
Okay.
Find the time required for the coin to hit the ground level. What is its position when it hits the ground? Or you can also call S of t its height, notice. In other words, referring to S of t as position is the same thing as saying the position is its height. Notice that after 0 seconds, its height is 1362, right? Okay, so they want to know what t is when the position, the height, is 0. So if I plug in 0 for S of t, that means it will have hit the ground, and then I just have to solve for t. Well, if I move the 1362 onto the other side, I get minus 1362. T squared equals, you have your calculator?
No. I'll pull it out real quick.
Well, t is the square root of that number.
Okay.
And you're going to get a plus and a minus, but this is one of those cases where you cannot have negative times. So you're only going to use the plus answer.
Oh, yeah, that makes sense.
Guessing 16 goes into that number 7 times. 70 times, maybe? I don't know. You got your calculator? No, it's going to be a perfect square. What is it going to be? 1362 divided by 16. No, it's not a perfect number. It's 85.125. It's the square root of 85.125. So t is the square root of 85.125. Maybe that's a perfect number. I don't know.
Yeah, that's 16.
Now I get 9.22. So after, in other words, if I take the square root of that number, I get 9.22. That's how many seconds it takes to reach the ground.
Okay.
Okay. And finally, find the velocity of the coin at impact. Our velocity function was, I erased it, but the velocity as a function of time was minus 32t.
Mm-hmm.
Well, we know that it took 9 seconds, 9.22 seconds to hit the ground. So what's the velocity when we hit the ground?
So it would be 16, 9.22 squared plus,
Whoa, hold on. We're talking velocity, not position anymore.
oh,
So you want to use the v of t function
so it's just negative 32.
times however many seconds it took to hit the ground. Remember, this thing is speeding up at 32 feet per second, That's its acceleration, is 32 feet per second. But I got to multiply this minus 32 times my 9.22, which is how long it took to hit the ground. What do you get? I got it right here. It's going 295 feet per second downwards.
Okay.
I don't see any dimensions or units on this. No, it didn't say feet per second, but that's what it is.
Okay.
In other words, it's not meters per second. Meters per second has a different coefficient than 16. Whenever you see the negative 16 as the first coefficient of your position function, that means you're going to be in feet per second.
Is that the rate of gravity?
The rate of gravity is actually 32 feet per second. And notice that if I were to figure out a of t, that's the first derivative of velocity, so it's minus 32. There's the acceleration function, and that's where you get your 32 feet per second.
Okay.
By differentiating your position function twice.
Okay.
Brianna, I gotta go. I got a 4:30. I hope that's
awesome.
Helpful.
Yeah, super helpful. Thank you.
Okay, talk to you next time.
Bye.